Chal, Camps on everyone. Let's start off. Hope everyone tried the two homework problems. What is the answer for this? Others? Camps on. Where are the rest? How do you do this thing? So, hope you remember last time we did the difference between a spring and a string. A spring will continue to exert the same force even after cutting, whereas a string will, the tension changes. So, initially, if you look at the forces kx, this was theta, and this was mg. So 2kx sine theta is equal to mg. So after cutting, if you look at the forces, this force will still remain kx and this weight will be mg. This will be theta and this will have accelerations ax and ay. So mg minus kx cos theta is equal to may, and kx is nothing but kx sine theta. So ay will be g by 2 and kx cos theta will provide the horizontal acceleration max. Kx is mg by, so gax will be g by 2 cot theta. Check your answers. So the moment you cut the right spring, the left spring will still continue to exert the same force kx. Like I said, the spring doesn't care. Spring will only see one thing. Is my elongation and the compression same or not? Ritu, Ronak, Camson. This was the last class ka homework problem that I gave. Some of you don't remember. Clear? What happened, Nisha? Looking tired? Health is fine? Sleepy? No. What about this guy? The second one, 49. Did everyone try? Forgot. T sine theta cos theta. What is that? That is the acceleration of the wedge. Okay. Let's see. I'll give you a minute. Try. 49. Remember the steps. Choose your system, draw the FBD. Define accelerations, find the constant between them. Write the equation, solve. The story is always the same. Get this? Try, I'll give you a minute. You are doing 49 right now. I'll send you a sheet on NLM today. Someone wants some tough problems, you can go to my module, 5 and 6. G cot theta. Try it, I'll give you a minute more fast. You should have tried this before only. Finish it off. After this, you have pseudo force. That is, like I said, we'll not do pseudo force much except a little. It is useless kind of thing here, but circular motion it will be quite useful. We'll start with friction today. Okay. Step 1, free body diagram. Theta, normal reaction. Extend this. So this will be 90 minus theta. So this will be theta. So components will be n cos theta and n sin theta. And this acceleration be a1. So n sin theta is equal to mass into a1. Now for the sphere, same thing. If you look at the components, this guy would be n sin theta. This would be n cos theta. Your own weight mg, n wall, and acceleration a2. mg minus n cos theta is ma2. Constraint equation. If this guy is going with a1, acceleration along the normal should be same. And this guy is going with a2. This is theta. This is 90 minus theta. So a1 cos 90 minus theta is equal to a2 cos theta. So a2 is a1 tan theta. We have done this constraint before. Then equation 1, 2, and 3. Take 3 and put it in this. You get mg minus n cos theta is equal to m into, and let's do one thing. Take this n also and put this thing here. So mg, n will be ma1 by sine theta. So that will be cot theta. ma2 will be a1 tan theta. M gets cancelled. We get g is equal to a1 tan plus cot theta. So that will be g by tan theta plus cos theta will be sine theta by cos theta plus cos theta by sine theta. That will be sine square theta plus cos square theta. Sine square theta plus cos square theta will be 1. So that will be g sine theta cos theta. Check. Once you got the equation, it is just a matter of math. Anika, you got it right. Aditya, you got it right. Two right answers. You got answers, you need to type it in the chat box here. Check. Standard process, huh? Meaning I'll tell you again, always remember your processes. All these additional formulas, extra shortcuts, वो सब ठीक है. But if you forgot your basic, right, you will not be able to think what is happening. Physics will start going a little weird. It is not fun that way. All that additional things are good, but you need to have a basic understanding of what's happening, why we are doing what you're doing. because this is how we will learn every chapter. Every chapter, there's a certain format. Because if you know the format, you'll know how to adjust. If you remember the shortcuts, you'll have a speed in the exam. So both play two different roles. If you're only good with the entire process and everything, you'll still do problems, but your speed might hamper. Advanced के लिए चलता है, but mains and bits you will get affected. When I was in 11th and 12th, now one of my friend, his name is Sabir. He was pretty good in physics. I think I told you about this guy. No, he's pretty good in physics. He's the guy who actually taught me some physics also. He's the one who used to help me a lot in 11th standard when I was having difficulty. But Sabir always had a problem, speed. We used to call him the goat because he used to have a small beard like a goat. So, and he used to feel proud about it. I don't know why, but okay. So this guy, his physics was very good. But end में, when we wrote AIEEE exam, my rank was All India 185. His rank was 9,000. The problem is speed. Just because your subject is good doesn't mean you're going to do well in the exam. But advanced exam, my rank was 360, his rank was 670 something. IIT Roorkee Computer Science. The advantage क्या हो गया ना? Advanced exam में questions are less than questions were tough. So he had more time to think and it worked out there. But when it is a speed exam, he could never compete with me, even though his subject is better. So one reason why I keep so many tests every week, I can't have one test. So you need to, just to give an example, most of you guys are too obsessed with this exam, like every question aana chahiye, every mark aana chahiye. Because of that, you guys don't try any new things on that. When it's a new thing, right, I'll tell you one thing. One day, right, we had a doubt like, if I guess what will happen? If we guess what will happen? You know what I did? I solved the entire paper, right? It was that time 60 questions, 1 hour, AIEEE pattern. I solved the entire paper and I guessed all the questions just to see how much will I get. And what I realized is I get only one answer right out of 6. मतलब मेरा luck कितना bad है. Getting it. So from that I understood I should not guess only. If I can't eliminate 2 options, I should not guess. I'm very bad at guessing. We literally used to do a lot of experimentation in the exams. And teacher used to ask also, क्या किया इस बार ने? Sir, we tried like this thing. Okay. So every exam is not about scoring. See, your PACE ka major tests are there, focus on them for scoring, but every test don't get scared and every test don't take it that rigorously. It is just for learning purpose. Big deal, you mess up 1, 2 exams, kuch nahi hoga. But if you're messing up the same chapter continuously 4, 5 times, something went wrong. You didn't practice. Next one, pseudo force. Listen carefully. It's an important concept, quite useful when we do circular motion. But as such, loss of motion, you can solve every problem without this. For some reason, right? Some people like to use pseudo force a lot in loss of motion, which I feel is unnecessary. It will you lose all the understanding. But let's see what happens.
No, can you go back for a minute?
क्या हो गया? अरे इतना story पता है. What were you doing till then?
Yeah.
Oh, you're listening to the story. That is fine. There is one guy in the class. He does that. When I say something, he keeps the pen down and listens calmly. Then he's like, he said, "Yeah, this guy will be a very bad driver. You should not talk to him when he's driving. He will just leave his hands and listen to you." Next thing, pseudo force. I hope everyone is giving the test. Next one, the loss of motion test is online till Thursday, I said, right? Yeah, so do make sure to give it. Next week, I'll not keep any test. I'll give a 1 week break and then we will again continue. We will have a test on kinematics, NLM. We will combine 2, 3 chapters now. You will get the new test schedule tomorrow. In certain cases, it is convenient to solve with respect to non-inertial frame. Yeah, it has its advantages with respect to non-inertial frame. Non-inertial frame is what? Accelerating frame. Any frame that accelerates is called non-inertial frame. But the problem with this is loss of motion are not valid. in non-inertial frame. But we are kind of used to, solving in non-inertial frames also. We want to use laws of motion. So what we do, therefore, we introduce a correctional factor. Now listen to the word. We introduce a correctional factor called pseudoforce. It doesn't exist. It is a mathematical thing which you have introduced in order to make the equations right. I'll give some examples. And the pseudoforce is given by mass of the body being observed into negative of acceleration of the observer. Example, let's say we have a person here who is going with acceleration a1. We have a block here going with an acceleration a2. So if I ask you to find pseudoforce on M as seen by man, now this is important. You have to define who is your observer. The pseudoforce will be mass of the block into acceleration of the man in the opposite direction. So minus a1 I cap minus ma1 I cap. This is independent of a2. Let the block go with any acceleration, I don't care. Pseudoforce depends only on mass of the body which you're observing and the acceleration of the observer in the reverse direction. It does not depend on the acceleration of the object which you're watching. Let me give you more examples. I'll show you problems, where it does help. Clear? Turn in the page. Clear, na? Neil, Abhinav, Pastika, Rona, clear? Now, examples. Let's say you take an elevator, you keep a spring balance, and you tie a weight M, and let the whole elevator go up with an acceleration. Now we have two observers, observer B and observer A. Now, if you ask them to draw the FBD, see what happens. If you ask A to draw the FBD, A will say, okay, there is a block here, M, there is a tension, there is an mg, and there is an acceleration. So he will say T minus mg is equal to ma, and he says tension is equal to m into a plus g. And when he looks at the spring balance, he gets the right reading. The spring balance also shows the same. Now, if you ask B to draw the FBD, B will say, okay, we have a block mass M, there is a tension, there is an mg, and acceleration is 0. I don't see it is moving. Because you are in the lift with the block, he thinks it is at rest. You getting the problem? And when he writes the equation, he get T is equal to mg, which is wrong. The loss of motion is failing. The problem is, because this guy is standing in a lift, which is a non-inertial frame, that's Newton's second law is messed up. It is not working out. So then we tell B, you're doing something wrong. You're in a non-inertial frame. So we tell B again draw, but this time with pseudo force. We tell him, since you're in an accelerating frame, you can't use the loss of motion directly, but use pseudo force. Now he will say, okay, tension T, the block ka weight is mg. Since I'm in a lift which is going up, the pseudo force will be mass of the body, acceleration of the lift in the opposite direction, pseudo force, which is not real, but I need to introduce this. And what about the acceleration of the block? It is still 0. He will still say block is not moving. Are you getting it? He will still say the block is not moving, which is true actually. In his frame, the block is not moving. Now, if you write the forces, T minus mg minus ma is equal to mass into acceleration, which is 0. He gets tension is equal to m into a plus g. Suddenly, the equation start becoming right. So this is without pseudo force, and this is with pseudo force. Are you getting simple example? This is what happens if you try to apply loss of motion in a non-inertial frame without putting pseudo force. Indirectly, what we did, T minus mg minus ma is there. You brought ma to the left-hand side and you called it a pseudo force, isn't it? Think about it mathematically. You simply took this ma on the right-hand side, you shifted it to the left, and you started calling it a pseudo force. Please check this example. That's it. This is the main idea of pseudo force. If you understood this thing, solving problems is easy. So whenever you stand in an accelerating frame, just make sure to include an extra term ma, where m is the mass of the body and a which is and a is the acceleration of the observer in the opposite direction to the acceleration. Anyone not convinced with this page, please ask. And remember, B will always think block is at rest. B will never say the block is moving. Han, Niranjan, clear with this? Mehan? Arjun?
Yes, sir.
Direction of pseudo force is negative of acceleration of the observer. तो observer का acceleration पे depend करेगा, right? Suppose if the lift was going down, then the pseudo force would have been up, right? So it depends on the observer का acceleration. Now let me show you examples like how to use pseudo force and solve. Suppose if they give you a question like this. Let's say this is block M1. This is block M2 and the lift is going up with it. And now if I ask you, find the acceleration of the blocks. With respect to lift and tension in the string. I'll show you this thing. See, so what we do, right? Step 1, if you look at any block here, the whole system, whatever, if you take any particle here, mg, we have done this in relative motion, if you remember, the pseudo force will be ma. I'll just take it as an example only. Idea is simple. So what we get is F net will be MA plus MG, which can be written as M into G effective. Do you guys remember this G effective, which I did in relative motion? Something of this sort. Okay, even if you don't remember, or we didn't do also, the same thing. G effective is A plus G. That means anyone in the lift will think the gravity has become A plus G. So observer inside the elevator will think this is a new gravity. G effective. Then you're done, na? What is the acceleration of the blocks? If you remember the formula, M2 minus M1 by M2 plus M1 into G effective. What is the tension of the string? 2 M1 M2 by M1 plus M2 G, but G ka place mein G effective. Wherever there is G, just replace with G effective and you're done. If the lift was coming down, it will be G minus A. If it is going up, it is G plus A. Wherever there is G, just dump G effective. But this will be the acceleration of the blocks with respect to the observer. If you want in the ground frame, वापस वो A को add करना पड़ेगा. So that is one main catch. Whenever you use pseudo force, you get all answers with respect to the accelerating frame. Have a look at this example. So basically, this is the idea that any mass inside the body will think the gravity has become G plus A. So simply equations में क्या हो जाएगा? It will be M1 G effective, M2 G effective, T tension, everything will same. Only G का place में G effective will be replaced. Sure, everyone? Same thing, you can use this in projectile also. Suppose you have a big container. Let's say this is going down with A, and someone throws a particle with U and theta. So this thing flies and falls on the ground. So if they ask you find the time when it reaches the ground, when it reaches the floor of the elevator. Same idea. So at any instant, the weight will be mg. Since the lift is going down, the pseudo force will be upward. So G effective will be G minus A. Time of flight ka formula is 2u sine theta by G. G becomes G effective. Range will be u square sine 2 theta by G effective. This would be the range. You get everything as seen by the observer. Wherever there is G, just put G effective and you'll get answers. So these are one type of models. Please check out the examples. So gravity would be G effective, which is G minus A. So every person in that elevator will think the gravity has become G minus A. Clear, everyone? Now, let's try to do the problem right in the ground frame and the pseudo force ka thing both together. Then you'll get a better understanding like what is the difference actually. It's quite useful, when they're asking to study with respect to like what is the displacement as seen by the observer in the left. Then pseudo force helps. Anything in the ground frame, better do in the ground frame. Now try this question. We have a vehicle which is going with acceleration A. Horizontal acceleration of the vehicle. Inside the vehicle, you have a pendulum, which is making an angle theta. And we have two people here. There is a person A on the ground and there is a person B standing inside. The pendulum inside makes an angle theta with the vertical. Find theta. Solve in the frame of A and B. Matlab, same answer you will get in both the frames. Exam mein to you just solve in one frame, but for you to understand and learn what is the difference between ground frame and pseudo force, we'll do in both the frames. Try. You got a minute or two. Yeah, standard one. See, if you ask A to draw the FBD, you know what he will draw? A will say there is a tension, there is an mg, that's it. There is no other forces. And acceleration is horizontal. So if you ask A to draw the FBD, he will say there are only two forces. And this angle is theta. So he will write T cos theta minus mg is 0 in the vertical direction. And T sine theta is providing the acceleration m into A. If you divide them, you get tan theta is equal to A by G. That is what A will say. If you ask B to draw the FBD, you know what B will say? We will say, okay, there is a tension, there is an mg. Since I'm in a non-inertial frame, I have to apply a pseudo force, which is mass of the particle, acceleration of the observer in the opposite direction. He will say, I will draw this way, pseudo force. And what is the acceleration? 0. I don't see it moving. We will think it is at rest. Now this guy will write forces T cos theta minus mg is mass into vertical acceleration, which is 0. So T cos theta is mg. And T sine theta minus pseudo force ma is max, which is also 0. So T sine theta is equal to mg. Divide them, you get tan theta is equal to a by g. Answer is same. But if you see their FBDs, right, they look quite different. I hope you're able to see the difference now. You could have solved the problem in the ground frame. You could have solved this in the, non-inertial frame. So A is the ground frame. In reality, there are only two forces and one acceleration. But if you stand inside the lift, you will think there are three forces and no acceleration. And the third force is not real. That is a pseudo force. I hope everyone is able to get a understanding what is pseudo force and what is ground frame. So if you ask me, sir, then shouldn't we use pseudo force? Nothing wrong. Pseudo force is good. You can use and solve, but just understand what you're doing. The moment you use the word pseudo force, you are keeping the observer inside the frame, accelerating frame. When you say I don't want to use pseudo force, matlab you're solving in the ground frame. But if you understood this much difference and if you use pseudo force, there is no problem. Problem jab aayega, when you start mixing up both the things. You don't know why you're using pseudo force and what purpose you're using. That is the problem. So whether to use pseudo force or not will depend on whom. It will depend on you. The first question you should ask is, do I want to solve in the ground frame? That is A. Do I want to solve in the Bika frame? Who is inside this thing? Once you ask that question to yourself, and once you decide I want to solve in Eka frame, don't even talk about pseudo force. If you say no, I want to solve in Bika frame, then use pseudo force. But we will think it is at rest. I hope everyone is getting this. That's it. This is the main idea of pseudo force. If you know this thing, there's nothing much there. It is the standard stuff. FBD, forces, equation, solve. Check. Let's do one more. Like I was saying, in loss of motion, I never really found pseudo force kitna big useful use. It has advantages maybe in friction, circular motion, but pure NLM, it is a waste. Concept is important though. Venkatesh, come on. Can I go ahead?
Yes, sir.
Aryan, Ritu, clear so far? Palaksh, Ali, clear. Venkatesh, Neil, Maulika, all clear so far. Udayan, Swastika, Niranjan, Rehan, perfect. Next one. The last one in loss of motion. Let's say we got a block M, we got a small m, and this is theta, and all surfaces are smooth. Find the acceleration of the wedge and the block. You can find one, you'll get the other automatically. This is a good one. Try. G tan theta. I don't know, you got such a good answer. I was not expecting that. Nee, I don't think so. That is the answer. Or maybe you remembered some other answer. Try, everyone. You can do this again in the ground frame or you can do in this frame. It doesn't matter. I'll show you both, but you do whatever you like. Ground frame or the pseudo force, whichever you like. But just before starting the problem, ask yourself, where is my observer? If you say my observer is on the ground, pseudo force ka baat hi mat karo. Forget about it. If you say my observer is on the wedge, matlab wedge is accelerating, so then you have to include a pseudo force. Try, everyone focus. Standard process. Draw the FBD, define your accelerations. That is the main part in this problem, defining the accelerations. And then find the relation between them and so on. Just give it a try. I'll just get some water. G sine theta minus A cos theta. What is A? So give me answers in some variables. If that is the case, I will say let the acceleration of the block be B. Answer is B. Okay, na, Anusha? That is faster. See, I'll show you in the ground frame. The wedge, normal reaction, your own weight mg and ground is anyway useless. And let this acceleration be A1. Theta, this is 90 minus theta, so this is theta. So components will be n cos theta and n sin theta. N sin theta is equal to MA1. Now listen to this point here. The block has a problem now. Acceleration kana, it's difficult to see how is the block going. So what we will do, let A2 be the acceleration of the block with respect to the wedge, not in the ground frame. Means any person standing on the wedge will think the block is going with A2. Because we know with respect to wedge, it will slide down. So what is the actual acceleration in the ground frame? Look at this thing. So if you look at the block forces, normal reaction, mg sin theta, mg cos theta, mg ka components, and acceleration, it will have two components. It will have an acceleration A2 along the incline and A1 backward because of the wedge. Are you getting it? The block will have two components of acceleration. Wedge is going back and the wedge block is also sliding down. So this is due to wedge. So if you look at the forces here, I'll just write the acceleration of the block. The block has actually two accelerations, A2 and A1.
Sir,
This
will
is
the
theta.
acceleration will be in the direction of
In the direction of
wedge, or will the acceleration will be same along the common normal?
God, what is A2?
With respect to wedge.
So in the ground frame, क्या करना चाहिए? Add the acceleration of the wedge.
Okay.
So if you take the resultant of these two along the common norm, it will be same only. Na? Here we're not talking any components का बात ही नहीं है. If you take components, you'll get the same. So this is n. This is mg sin theta. This is mg cos theta. And look at the accelerations. It has two accelerations. A2 minus A1 cos theta. And this will be A1 sin theta. So even along the normal, there is an acceleration component here. And this would be mg cos theta minus n is equal to ma1 sin theta. Mg sin theta is equal to m into A2 minus A1 cos theta. Check your equations. Along the incline and perpendicular to incline. This is the acceleration of the wedge in the ground frame. Blocks in the ground frame. This is the acceleration of block. It has two components, one along the incline and one perpendicular to this thing. I hope everyone is getting what I did here. Please ask me. This is the main thing in this question. Right? It is sliding down with A2 and the wedge itself is going with A1 to the left. So resultant acceleration will be, you have to take the components A2 minus A1 cos theta along the wedge and A1 sin theta along the incline. And then we got three equations. Just a matter of solving. n sine theta is ma1. mg cos theta minus n is m into a1 sine theta. mg sine theta is equal to m into a2 minus a1 cos theta. Take this thing and put it here. Take a1 and put it here. If I put it here, this will be mg cos theta minus capital ma1 by sine theta is equal to ma1 sine theta. So I get a1 is equal to mg cos theta by m plus small m sine square theta into sine theta. This is the a1 acceleration of the wedge. Ho gaya directly. This is what I wanted actually. 2 steps mein ho gaya. But if you want to find acceleration of the block also, we have to take this and now put it in this guy. That would be mg sine theta is equal to mm will cancel. G sine theta is equal to a2 minus mg cos square theta sine theta by m plus m sine square theta. I will leave it to you. I won't simplify. That would be the acceleration of the wedge. First of all, please check this page. This is the main thing. Once you got the equation, it is just a maths after this. But getting this equation is important thing. You cannot find the acceleration of the wedge directly because of the block directly, because I don't know how the block is going. The block is sliding also, block is going back also. So it is a resultant of these two. If the wedge was rest, you are pretty sure the block was sliding along the incline. If the wedge started moving, it's a painful thing. This is how I did in the ground frame completely. Pseudo force, I'll just show the equations. You can try that if you want, but please have a look at this. It's a good one. Any step you're not convinced or not clear, please ask. Clear? This is the solving. And again, I'll tell you, most people, right, are lazy to solve. When they get equations, the irritating part is they get frustrated to solve. And this especially happens, right, when you're a little smart. That I have seen. You think like, अरे कौन करेगा, आएगा answer exam में, नहीं आएगा exam में answer. Because you are lazy at home to solve, and you think you're too smart, you are lazy, you don't solve, and you get messed up. Advanced में papers come lengthy. Physics paper, I'll tell you, I think 2019, I guess. I don't remember the year. Paper was dead easy, but it was damn lengthy. 1 hour, 10 minutes लगता था paper solve करने, to solve the entire paper. People who are lazy, right, they got frustrated and left the questions. Meaning there was one question, where you simply had to multiply 1.0053 with 931.5. If you do this, you'll get 4 marks. Advancement. There was a small calculation like this. That's a simple problem. People were lazy to solve. Clear? So if I try to do this in the pseudo force, meaning the moment you say pseudo force, you're keeping the observer here. Kuch difference nahi badega. Everything will look same. So my observer is here now. So if you ask him to draw the FBD, this is what he will say. This is going with A1. So he will simply say normal reaction, mg sine theta, mg cos theta. Since I'm accelerating, this thing will be mass into A1 pseudo force. And since I'm on the incline, I will think it is only going this way, acceleration A2. Observer thinks the block is sliding along the incline. That's it. Write the equations and finish it off. So instead of splitting accelerations, you're splitting pseudo force now. So the forces will be now mg sine theta plus ma1 cos theta is ma2. And this will be n is equal to mg cos theta minus ma1 sine theta is 0. You get the same answers. So like pseudo force, ground frame really won't make much of a difference. So this is with pseudo force. So here my observer is on the wedge. In this problem, it really doesn't matter much actually, because at the end of the day, even in ground frame, you defined A2 and A1 and then solved. You're getting what you're doing? In ground frame, you're saying the block has two accelerations and you divided the accelerations. In the non-inertial frame, you're saying the block has a pseudo force and one acceleration. Simply, you converted that horizontal acceleration into a force. Check. Clear? There. With that, we're done with laws of motion. Make sure to try. We have done almost 51 problems. And in that, some of them has ABCs and all. So overall, it is much more than that. Should definitely go through the notes, and you have to stick to your finish of your PACE booklet. And if you're solving any reference book, you can do that. But if you ask me, you can just stick to notes. Notes should be your primary material. Then you can stick with your PACE booklet or any whatever booklet you're solving. If you're from Allen, solve Allen ka booklet, it's also good. PACE booklet is also good. All are copied from Bansal only, so there's no problem. They all are good materials. And third, if you want to solve, you can go with my material. That is also copied only from Hyderabad. It's also a pretty good material, right? So that is also good, especially level 5 and level 6 who wants to do some tough problems. But if you're finding, sir, easy problems mein mujhe difficult lag rahe hain, then go from level 1 to level 4. Even if you go from 1 to 4 properly, advanced ka maximum questions will get covered. For people who want to challenge themselves, you can do 5 and 6. I think that will give enough questions actually. There's no need to buy any other book and everything. फिर भी you want to get a book, take a book. Doesn't matter. You want to do Cengage, DC Pandey, but take a book which you can solve completely. That's it. Don't go beyond 3 books, 2 books, your class ka material and 1 reference book. That is your choice. I won't say what and all. You choose. बस इतना करो, but अच्छे से करो. काफी matter, like you really understand what you're doing and why you're doing. If you take my booklet, that will give you ample of questions to finish it off also. So that is one. Don't run behind materials. People will come and say, पता है मैंने Cengage पूरा complete कर लिया, पता है मैंने वो book कर लिया. People like to show off. What they don't tell you is they're sacrificing maths and chemistry ka time and doing physics. Or someone is doing more maths and sacrificing chemistry ka time. Or maybe someone is really smart and they're doing it. Fine, then big deal. That is not my problem. So what will happen? You will hear from 5 people. One person will say, पता है मेरा maths सब हो गया. Another person will say, पता है मेरा physics सब हो गया. Another person will say, मेरा chemistry सब हो गया. Now you start making an assumption. सब लोग सब कर रहे हैं. I am only idiot. I'm not doing anything. This is called Instagram effect. Ever seen an Instagram? You go there and open Instagram. You will see people with happy faces, celebrating, enjoying, very happy. No one keeps Instagram a photo, right? Today I got fired from my job. Today my dog died. Today my mom hit me with slipper. No one posts these kind of stuff. So what will you think? Day one, you have 100 friends. I'm sure you have more. 3 people post something good, positive news. Next day, another 3 people will post. Another next 3 days. After 1 week, you will think everyone is happy in the world except me. This is called Instagram syndrome. That the entire world is happy, and for some reason, your life is hopeless, messed up, and it is pretty sad. It is not. You're much more happy. So, don't worry what others are doing. Let them go to hell. You focus on yourself. I'm telling you seriously, you really want to crack the exam, that's what you do. You focus on yourself. Last exam में 100 में you got 60, इस बार 70 लेके आओ. 70 आ रहा है 80 लेके आओ. 80 आ रहा है 85 लेके आओ. 85 आ रहा है मेंटेन करो. मेंटेन करो. I won't say 100. मुझे पता है once you touch 85 90 it becomes very difficult to push through. मेंटेन करो. अभी बाकी सब्जेक्ट में 85 लेके आओ. Sir, I got only 40 marks. The other person got 100 out of 100. Let him go to hell. That is not your problem. What will you do if you got 100 out of 100? You'll sit and cry. What will happen? Nothing will happen. You focus on yourself. You know what will happen? If you focus on the other person, I have seen what happens. Every day you're sitting and crying, others are getting more than you. You go to the exam, you don't get the first question, you don't get the second question, you don't get the third question. You know what is going on your head? अरे यार ये एग्जाम भी गया, मुझे कुछ भी नहीं आ रहा है, पेपर टफ है, बाकी सबका मार्क्स आ जाएगा, मुझे मार्क्स नहीं आएगा. Did you see? Instead of thinking how to solve the questions, bloody, you're thinking of every damn negative thing in life. Everyone will get more marks. People will what will think about me. I'll tell you one thing: no one has time to think about you. You are really not that important or popular for others. No one gives a damn about you. If you score even 0 and other people score 100, no one is talking about you. Everyone has their own problems. The guy who got 95 is crying, अरे एक question चला गया रे करके. Do you really think he has time to think about it? पता है उसको 0 आया. Let's laugh at him. Bullshit. So if someone has that feeling, some of you have, so please get out of that. Ignore others and you just focus on yourself. As long as you keep improving, you will reach. What others do is none of your business. So, but main thing, you need to work. So keep that in mind. Next thing, because I know you guys just came out of school, वो comparison सब होता है. Don't fall into that trap. Let's see, friction. Quite an interesting chapter. If you want me to summarize the entire chapter in 1 or 2 lines, this is what I'll summarize. Let's say there is a block here of mass m, and there is only one force acting on the block. One force. And if I want to find the acceleration, magnitude, and direction, what information do I need regarding the force? If there is only one force acting on the block, and I want to find the magnitude of acceleration and the direction of acceleration, what information do you need regarding the force?
Magnitude and direction.
Right? If I know the friction force ka magnitude, and if I know the force ka direction, my job's done. That's it. This entire chapter teaches you only one thing: how to find the friction ka magnitude and friction ka direction. If you know how to find that, put it in a free body diagram, draw an FBD, write accelerations, equations, solve. It becomes exactly laws of motion again. Now let's see why it is such a weird thing to find direction and magnitude. So friction, it has only one purpose in life. When two surfaces are in contact, there is an opposition to the relative motion between the surfaces. This property is called friction. And the force responsible is called frictional force. But then again, we call it friction only. We are too lazy to add more. This property is called friction. Now, look at this thing. The most important word in this statement is friction does not oppose motion. Most people have this wrong statement. They ask you what friction does opposes motion. Blunder. Friction does not oppose motion. It looks like that sometimes. It opposes relative motion. Be careful with that. Tell me one thing, when you're walking, who is making you walk? When you're walking, your speed is increasing, right? That means someone is pushing you. Who is pushing you? Ground? Ground nahi hote. There'll be some force, right? Force. Which force? If you look at your leg, right, how you're walking, think about your leg. Let's say this is your leg, right? You know how you're walking? When you put your leg on the ground, you're trying to drag it backward, isn't it? Isn't that how you're trying to go backward? So that means the point on your heel is actually trying to go backward. The heel is trying to slide backward. Think about it. Isn't that why your chappals ka piche becomes thinner? Observe anytime when you took your footwear, the back of the foot, right, becomes thinner because of this only, because the heel is trying to rub backward. So because it is trying to go backward, the force will be friction will act in the forward direction. So friction is actually responsible for you to walk. If there is no friction, you will do moonwalk. You'll be at the same place and you'll be doing like this. You'll not go forward, you'll not go backward. So when you're walking, friction is responsible for your motion. So friction does not oppose motion. Friction is actually causing motion here. So friction is responsible when you walk. It doesn't oppose motion. So people think like that, I'm walking forward, so friction piche hai. No, because of friction, you're walking. You have to observe the point in contact. Your foot on the ground is trying to slide backward to stop that the friction is acting forward. How does the friction act on your cycle ka wheel? Let's say you're going on your cycle. How is the friction on the wheels? Forward. This is more interesting. If you look at your cycle, I know it doesn't look like one, but ignore it. I can't draw better than that. That's your cycle. Okay, that's a cycle. Now you tell me, when you're pedaling the cycle, right? What are you doing? You're pedaling the cycle. So did you ever try this thing? You put the cycle on the stand and rotate the pedal and then leave the cycle. Kya kabhi? If you have not done that, you didn't have a good school life. This is what happens. So if you actually lift the back wheel and if you rotate and leave it, right, you'll observe the power is only going to the back wheel. Whenever you're pedaling your cycle, the power only goes to the back wheel. So when we pedal, we are trying to rotate the back wheel. The front wheel actually has nothing to do. There's no power only on the front wheel. We are trying to rotate the back wheel. That means the back wheel, if you look at it, because you're pedaling, it's trying to go this way. So this point is trying to go backward. So its point is actually going backward. So the friction will be forward. But look at the front wheel problem now. The front wheel, this spoke, right, this pedal which is there is pushing it. The front wheel is being pushed forward. It does not want to move only. Am I writing wheel ka spelling right? It is a double L or single L?
That's right.
Right only, I guess. Okay. Is being pushed. That means this point is actually trying to go forward. The friction will act backward. It will be different. So friction on the back wheel will be front and the front wheel will be back. So imagine you have a car going and you want to stop the car. What are you supposed to do? If you can just lift the back wheels, car won't move only. You're getting it? If you just lift the car with the back wheels, the wheels will simply rotate here. The car won't go only. The car will be at rest. Are you getting this? Because the front wheels do not have any engine. most of the cars that we use, right, are two-wheel drives. Four-wheel drive alag story hai. What are the most of the cars we use are two-wheel drives. Ever heard this term? Two-wheel drive, four-wheel drive? Two-wheel drive meaning only the car ka two back wheels, right, are given power. Meaning only two wheels are given power. Most of the cars in India, right, are back wheel, two-wheel drives. Matlab the engine is only connected to the two back wheels. The front two wheels have no power at all. So if the car gets stuck in a mud, the back wheel, that's why it doesn't come out. Because the front wheel does not have any power to pull out. It simply just keeps rotating at the same place. But if you look at all military vehicles, right, they're four-wheel drives. Means the front wheels and the back wheels both have engine connected. It gives you more stability, but problem it is expensive. To put an engine connection from front and back, it becomes expensive. So day-to-day use mein itna kya hoga? So, but military people, you need to be more secure. You don't want your engine to, one of the wheel gets damaged or something, you still want it to drive. If it's a four-wheel drive, friction will be forward for all the wheels. Means somehow, if you can connect this pedal to the front wheel also, then friction also will be forward. To give a more analogy, think of like this. You're trying to push your friend who does not want to go to the class, and you're pushing like this. Can you tell me how will the friction be on both of them? Just give me a minute. Someone is ringing the bell. Yeah, some Amazon parcel. So, how will this guy look like? You tell me. So, if you're pushing your friend, let's say A and B, A pushes B. So, friction on B will be backward, whereas on A, friction will be forward, right? Isn't it? A ka legs are slipping backward, so friction आगे होगा, and B is trying to slip forward, so friction will be backward. Is this diagram making sense? So in this case, can you see A is behaving like back wheel? This is what is happening in a cycle. The back wheel is trying to push the front wheel. B is behaving like the front wheel. Be careful. This is a very good theoretical question. Bits of CET. When a car is going, what is the direction of friction on the back wheels and the front wheels? Forward and backward. Is this clear, everyone? Please check. Anyone not convinced? Ask me.
मुंबई के एकदम सेंटर में 5 एकड़ का जमीन दिलवा रहा हूँ 1000 इंस्पेक्टर यशवर्धन
तेरी पेशियां
वो भी
Now, we will not see the full movie, but
साल पहले मेरी बीवी मर गई थी इधर नहीं
we don't want to see John Abraham fighting.
रुको यार धरो मत
Look at the scene. The villains are trying to run away. And the John Abraham wants to stop the car. Now, since he has studied 11th and 12th some physics, and he became a good police officer also, so it will help him to stop the police. And plus, he has to do some gymming also. भी करना पड़ेगा. this is what it did. Once you lift the back wheel, right, both the wheels are simply rotating. The front wheels are down power only. So no matter how much you accelerate, the car won't go. See. There, can you clearly see? This is what I was saying. The engine entirely is powering only the back wheels. The front wheels have no power. If it had been a four-wheel drive, it would have dragged John Abraham with it. So the villain should have spent more money on buying a four-wheel drive car. But he's also trying to save money. And now see what happens if you leave it. There, if you leave it, that's what happens. Because the moment it falls on the ground, suddenly it accelerates and you go off. Clear? I hope now everyone agrees the front wheel, back wheel friction and all. Abhi thoda clarity aa gaya hoga. Thanks to John Abraham. Clear? Dekha? So if someone goes to movie with me, this is what happens. I'll keep on thinking, oh, friction dikh raha hai yahan pe. So there. Clear. Next thing. So why are we getting this friction actually? If you go to the molecular level again, there are two reasons why you're getting friction here. Or you can say two popular theories which are there. Interlocking and cold welding. Cold welding is the most accepted one. What interlocking says is, even though when you say a surface is smooth, in reality, surfaces are never smooth. At a molecular level, surfaces are interlocked. So if you look at this surface here, and it's like kind of zigzagged actually, meaning there's an interlocking. So because of this, right, if you try to move the surfaces, you get forces between them. Bollywood doesn't obey generally, but in this case, it obeyed. ऐसा तो where did Hollywood obey? Right? Entire Marvel का movie will be nonsense only then. Hulk can't exist. Ant-Man is a big nonsense. There are a lot of problems there. Just think about Ant-Man. When the Ant-Man becomes big, what is constant? Is the mass constant or density constant? Generally, law of conservation of mass. Right? If you say mass is constant, what happens since volume has increased, density will decrease. If he becomes 100 times bigger, then the density will become 100 times smaller. So this guy will become like a balloon and float in the air. And you think about it logically, if the mass is same, when he stands on the tank, why it should get crushed? Mass is same. But if you say, no, sir, density is same, then where did you get the extra mass from? Law of conservation of mass is not valid. Hulk, think about it, every time he becomes big, he becomes heavy. Where are you getting that extra mass from? Iron Man can't fly. Chalo, Thor, he says, I'm God, karike pura physics ko, he just throws it away. If you see, everything is like that. I think the only superhero I'm okay with it and accept is Batman. His superpower is being rich, which is a very reasonable, power. Any other superhero, you have some loopholes. Anyways, that is fun. So if you are a science student, Batman should be your favorite hero. But fine, if you have some other one, we still okay with it. Next thing is cold welding. So what is this cold welding? Whenever, these two surfaces are in contact, when you say two surfaces are touching, in reality, right, only very few points are touching each other. For example, if you try to, just try to put your hands together like a namaste types. And if you observe, see how many holes are there in the middle. Is it seriously your hand? Every point is touching, yeah? If you actually see, very few points are touching. Most of your hand is not touching only to each other. There are a lot of holes in between. Getting it? So whenever you say two surfaces touch, these points, right? Very few points are touching here. That means the entire weight will fall only on these few points here, which generates a high pressure. Approximately 1 in 10,000. For every 10,000 points, only one point is in contact. Approximately. So if there are like 10,000 molecules, only one molecule, that repulsion is pretty close. So when you bring two surfaces very close, so this word, right, in contact itself is actually wrong. The entire thing doesn't touch each other, right? Only very few points are contact. And you know what happens if few points are in contact? It is just like trying to standing on your toes. It puts a lot of pressure. This generates, this leads to high pressure. Which creates bonds. So the molecules actually start forming some kind of covalent bonds. So these are called cold welding joints. It's like you're joining two materials without welding. Welding is what generally we heat it up and we weld them. So, but here you're not heating it. That's why we call it cold welding. They are called cold welding joints. So basically they'll start acting like some kind of springs or something between them. It's like bonds between them. Clear? First page of friction. Clear? So that is one. Next thing, if you take, let's say you take a block here of mass m, or if you take a block with a wider area, but same mass m. So we have a larger area here and a smaller area here. So the difference will be you have less bonds here, but they're stronger. Most of the weight is only on 2 points. So we have a higher pressure. Therefore, this will lead to strong bonds. Here we have more bonds, so less pressure, weaker bonds, but you have more bonds. So overall, right, it gets compensated. The total friction will remain same. Friction is independent of surface area. So that's your first statement. Friction is independent of surface area. You take an area 1 meter square or 100 meter square, as long as you keep the mass same and the material same, it doesn't depend on the surface area. Next thing, friction rate. if you take a surface and if you try to polish it, generally what people think is if you polish it, friction decreases, which is true. But then what happens? If you polish too much, the friction actually goes up. The reason when you're polishing, initially the interlocking will decrease. But if you keep polishing more and more surface will come into contact. And the problem here is you're changing the nature of the surface. It is not the same surface anymore. It has becomes a different kind of surface. So the friction coefficient will change and that will mess up the whole thing. So you can say more of interlocking, more bonds will come in contact. So actually very smooth surfaces have very high friction. If you take two copper plates and make them very smooth and make them touch, right, it becomes very difficult to pull them apart or slide them across each other. So this word, smooth surface, is actually a wrong statement we are using. We should say frictionless surfaces. Smooth surfaces have very high friction, but then again, we just use the word variable there. So initially friction decreases. So whenever you polish a surface, initially friction decreases and then increases because interlocking decreases. I know we said it does not depend on area, but what happens, right? The surface ka nature will change. Coefficient of friction will change. And if polished further, cold welding increases. Yeah, you can say like that. Generally, problem kya aega pata hai? How do you think a smooth surface will look like? If you have a perfectly smooth surface, how do you think it will look like? What is your visualization? You visualize something like a flat surface, right? It doesn't look like that. You know how it looks? Imagine a box of laddus. They're like molecules, right? This is how it looks, isn't it? If you take one surface on another surface, what you're doing is you're keeping another molecule on top of this. So they're forming bonds with each molecule, isn't it? That means if you can take imagine if you can take perfectly smooth surfaces, if you can, which is not possible. And if you actually join them, what will happen? They'll become one single block. Happens with ice. If you can exactly slice it smooth surfaces and if you touch them, right, every molecule will form a bond with other molecule and the whole thing becomes one single block. It doesn't happen on Earth because if you take let's say an iron block, the moment you bring it to the atmosphere, pure iron, it becomes rust, Fe2O3. So that rust will form a layer here or the air molecules will be stuck in the middle. So if you take two iron blocks and try to stick, right, they won't stick to each other. But if you take two pure iron blocks in vacuum and if you try to stick to them, they'll become one single block. They should be smooth though. So I'll just on the page. So main thing here, remember this, smooth surfaces have very high friction. So till now in NLM, we kept on using the word smooth, but it's actually wrong. High friction. So we should say frictionless surface. Please have a look at this. So there, now we know what is friction and why do we get it. Now we will see the main two things, finding the direction and the magnitude. We'll finish off the theory today. Clear? Now, listen carefully. This is the main important 2 points, finding the direction and the magnitude. If you know these 2 things, chapter is over actually. Finding the direction of friction. We finish with the 3 today. Next class we'll do more problems. Step 1. First, assume surfaces are frictionless. So whenever you have 2 surfaces, assume there's no friction between them. Just an imaginary thing. Then see if there is no friction, see how they would have moved. See the tendency of the blocks to move or the surfaces to move. I'll give you examples. Then apply friction in such a way to oppose the relative motion. So one thing I like to tell you before going ahead, see, whenever you have 2 blocks or 2 surfaces touching each other, right? The cold welding joints, which we said, right? They're like kind of like springs. Imagine these cold welding bonds are similar to springs connected between the 2 surfaces. If you think like that, it will be more easy to figure out why this is happening. Are similar to springs between the 2 blocks. Just have a look at this picture. Clear? Let's see some examples. So I'll give you some blocks and things. You have to tell me the directions. Case 1, block A, block B. Let's say A is going with 2 meters per second. Now don't worry like who is giving, what is giving, ja rahe, 2 and 3. What will be the friction between A and B? Now think like this. If there is no friction between them, who will go faster? B will go faster. Now think of like this, okay? There are 2 of your friends. You are there in the middle, okay? This is you. So your friend A is there, your friend C is there. Now your job in the middle, B, which is the friction. Now listen carefully here. Your job in the middle is to what? To keep A and C together. You're getting it? Simple. That's what friction does. It tries to keep the 2 surfaces together. Now, let's say for some reason, C started running away with 10 meters per second. What can you do to keep A and C together? A and C are 2 people. You're there in the middle. You're trying to keep them together and C started running with a 10. What can you do to keep A and C together? You can stop C. You can do that one. Or forget about C. Make A also run with 10. Remember, end of the day, your job is to keep them together. I never said you have to stop anyone. You can make A also run with 10. Or you can decrease C to 5 and increase A to 5. Then also they're together. You're getting it? You have 3 options with you. Stop C, or forget about C and make A run, or decrease C ka speed and increase A ka speed. The friction takes the third one, because whenever you try to stop C, you get some force. That force you can use by third law on A and increase is acceleration. So Who is going faster here? B is going faster, A is going slower. So your friction here, what is your job? Oppose the guy who is going faster and support the guy who is going slower. Make sense? Let's say this guy is going with 1 meter per second. This guy is going with 2 meter per second. Now, both your friends are running away. What you do? You stop both of them. That is the only way to keep them together, isn't it? So in this case, you're not supporting anyone. You're opposing both of them. So if you're thinking exactly what is happening, so this is what is happening. The springs will become like this, isn't it? How will the spring force be? The spring force won't be like this. The springs will always pull. So just imagine there are springs between the surfaces. If A is going, actually diagram now will look like this. A is going slower, B is trying to go faster. If this happens, the bonds between them will stretch like this. And we know springs always pull. So this friction will be forward and this friction will be backward. Is that making sense? Like springs, if you imagine. What about Sika answer? This is going 2 meter per second. This guy is also going 2 meter per second. Answers anyone? What is the friction here? 0, right? If both are going together, why should I go and pull anyone? There will be no friction. There's no relative velocity. Clear? Next thing. Let's say speed of A is 5 meter per second. Acceleration of A is 2 meter per second square. Speed of B is 2 meter per second. Acceleration, let's say this is 10 meter per second, and acceleration of B is 1 meter per second square. Now, what's the direction of friction? Or wait, I'll give you a simpler case. This is also 5 meter per second. Now, so first priority will be always velocity. Wait. Yeah, okay. If velocities are same, then compare accelerations, because next moment the one with more acceleration will go faster. Getting it? If both are same velocity, then you compare accelerations. If velocities are like, let's say A is more than B, I don't care about accelerations. Accelerations come second. So in our case here, B is going slower and A is going faster. Next moment A ka speed will increase. So oppose A and increase B. This is a good one. Now, case 5. There's a slight problem in case 5. See, if you take velocity of A is equal to velocity of B, this will be 4 plus 2t is equal to 10 plus t. We get t is equal to 6. Meaning for t less than 6, B is going faster and A is going slower. So friction will be backward and friction will be forward. For t greater than 6, VB is greater than VA. For t greater than 6, VA becomes greater than VB. A starts going faster. Friction doesn't care what force, what it simply sees simply who is going faster and who is going slower. The friction ka direction will change in the middle of the time. After 6 seconds, it will be different. Before 6 seconds, it will be different. This is the reason why friction was so dangerous. It had a separate chapter of its own. Till now, you think about it, in laws of motion, did any force, suddenly change directions? Mg was there, it is always mg. Tension was there, it is always up. Friction doesn't care. The moment A tries to go faster than B, it will suddenly change direction. Case 5 is important. So friction ka direction will change. Clear? Any doubts on this thing? Aryan, clear with this? Ritu, clear?
Yes, sir.
Venkatesh?
Yes, sir.
Udyan, clear with this? Next thing. Case 6. All surfaces are rough. Even the ground is rough. Now, find the direction on ABC, D. Now remember, every surface will have one friction. Now draw the direction of frictions on ABCD. Just the directions. We don't care about the magnitude right now. Just get the directions. Just get this. Let's see. Yeah, all frictions. Now think of like this thing. Let's say A is there, friction is there, B is there, friction is there. That catches the friction between B and C, right? The friction between A and B doesn't care what C and D are doing. You're getting it? Every surface is independent. It will only look about itself. Like they're all selfish. Like A and B will not care about what C and D are doing, what B and C are doing. So every surface will behave independently as if they don't care about other surfaces. So you just have to look at case 1 to 5 in this thing. Now look at A and B. When you're comparing A and B, who is going faster? A is going faster. So this friction will be backward and this friction will be forward. That's it. The surface will care only about the friction will care only about the surfaces in contact. It doesn't care about the blocks. Now between B and C, who is going faster? Both are going opposite. So this guy will be backward. On C pay, it will be backward. So between C and D, who is going faster? C is going faster. D is going slower. Between D and ground, ground is not moving only. So this is F4. Check. Every surface, you just have to, when you talk about B and C, don't talk about any other surface. You just see B and C, what they're happening. This is looking like case 2, right? Both are going in opposite directions. When you look at between C and D, just look at these two speeds. I don't care about A and B and everything. So if you have multiple blocks, you can just treat two blocks as one thing, and you can just use case 1 to 5 and solve. The friction car direction does not care what other surfaces are doing. All clear with this? There. If you understood till here, that means you know how to find the directions. Please check. The next one, how to find the magnitude. Can I go ahead? Niranjan, Palaksh, clear now?
So can you
Anushka?
explain between B and C?
B and C, dekho na, B is going this way, C is going this way. Both are running away. What will you do? Catch both of them and pull them inside, na?
Yeah.
So pull them inside. Na?
Okay.
If both are running away from you, what you do? You catch both of them and pull them inside.
Yeah.
Okay? Next thing, finding magnitude. Now this is completely experimental. So the experiment goes like this. We have a surface, we have a block M, and here we have a bucket, and you're putting sand inside. So as you're putting sand here, this mass will be mg. This is variable because as you put more and more sand, the mass will increase. And this is the tension, and the same tension will act here. So the friction should act backward, and the normal reaction and mg. These are all the forces. Now in the experiment, what we observe, now like I said, we have to take observations from the experiment. As m increases, that is a sand, we observe the block does not move. This is an observation. So tension is equal to mg, and tension is also equal to F. So F is equal to mg. That means as m is increasing, the friction is also increasing. That is, friction increases. So as you put more and more in sand, friction increases, and after a certain time, the block suddenly moves. This is what we observe in the experiment. Now we need to make a sense of what is happening exactly. So when you plot a graph, you will clearly see what is happening here. Clear? Now, so when you try to plot this graph of friction versus the mass of the sand, we observe the graph kind of goes like this. First, as the mass increases, friction increases. And then for some reason, it just drops and then it becomes constant. So if you try to mark the points here, let's call this thing O, let's call this thing A, let's call this thing B. So from O to A, right, we call this thing static friction. Static meaning there is no motion, there's no relative motion. And this is called kinetic friction. I'll define. So what is happening here is in the region OA, the block does not move. That's why we call it static. The friction is there when there's no relative motion. Block does not have relative motion. At point A, the friction becomes maximum. So at one point, the block reaches max friction value. So this is called F static max. Then once you cross B in AB, right, why does the sudden drop? Once you reach the maximum value, if you try to apply a little more, the friction suddenly drops. The reason friction drops when the surfaces move. The reason is, think of it like this. Imagine you're standing there, I come and I catch you, okay? Case 2, you're running and I'm catching you. Tell me which one is more easy. In which case do I get a better grip? When you're standing or when you're running?
Standing.
When you're standing, right? So the moment the relative motion starts, what happens, you have broken all the cold welding joints, right? When you say you're moving means what did you do? You have broken the bonds. And once you started moving, you're trying to form the bond, but you're not giving enough time for bonds to form. Are you getting it? Once the relative motion starts, the bonds which are forming are not as strong as the bonds, when you're at rest, because you're not giving time to form. The bonds that are broken and they do not have enough time to form the bonds completely. They do form bonds, but you do not get a proper grip. It's like when you're running, it is more difficult to catch you. You might slip. So they do not have enough time to form the bonds completely. That's where the friction drops. But for example, let's say you stop the block for a second and again, if you start again, friction increases. They do not have enough time to form the bonds completely. This leads to decrease in friction. So whenever the surface is moved, the friction is actually less compared to when the surface is maximum friction when it doesn't move. And once you cross B, after B, the block friction becomes constant. And friction is constant. It does not change anymore. You have reached a maximum value. We call this thing kinetic friction. Please have a look at this picture.
Everybody go back to the previous page. Any doubts in this thing, please ask. Yeah? Yes.
Like I said, the main thing, how to find the magnitude and the direction chapter is over actually. Meaning conceptually it is over. We'll do different models though. Can I go ahead? So now, if I try to put all this in mathematically, so what we observed from this experiment, like I said, it is all experimental here, N, mg, and this friction. So the experimentally, we find out that F static maximum, that means when there is no relative motion, the maximum value is proportional to N. So F static max is equal to mu into N. Now be careful here. You're only comparing the magnitudes. F bar is not equal to mu S into N bar. Because if you see F and N bar are perpendicular to each other. This is mu static mod N bar. You're only comparing the magnitudes. Directions are different. So this is the important thing see here. So here mu S is called coefficient of static friction. It depends on the material. So just to put on the formulas. So F static maximum value is mu S N. If this is the maximum value means what? The static friction is always less than or equal to mu S N. And F kinetic friction is equal to mu K into N. If someone asks you what is the value of friction, always say Fs is less than equal to mu S N. Never say equal to mu N. Mu K is coefficient of kinetic friction. Mu K and mu S will depend on the material. Basically, friction depends on the normal reaction. Now, what do you mean by static maximum is mu N, F static is less than equal to mu S N? Just let me give an example. I'll turn the page. Look at this example. Let's say we have a 5 kg block, and let's say mu is equal to 0.5. And let's say you're applying a force of 5 newtons. What do you think will be the frictional value here? What should be the force, frictional force? Now see, listen carefully here. So Fs maximum is given by mu S into N. So here is mu is 0.5 and N is 50. So we are getting this is 25 newtons. You know the meaning of this? This is the max value of friction that I can give. But now you tell me on this block, you're applying only 5 newtons. If you apply 25, what will happen? Block will go back, right? Can you see what will happen? Just imagine in your house, you're trying to push the table and the table comes towards you. There is a ghost in the house. Isn't it? First thing you'll run away from there. It's pretty scary. So what will the friction do, right? See, again, listen carefully. What is friction ka job? Friction ka job is not to give maximum force. Friction ka job is to make sure there's no relative motion. If I give 25, you know what is happening? I am making the block move backward, right? I'm actually messing up my own job. My job is not to move you, but I'm only moving it. So what will the friction say? Okay, I'll just give you 5 so that you won't move. But we need only 5 newtons to stop relative motion too. I can give 25, but I need only 5. So friction will be 5. This is what I was saying. Friction will be always less than equal to maximum. Let me give you a more crude example. Okay, listen carefully. Let's say you have 1 lakh rupees with you. And you're ready to give it to me. Okay. Now, if I ask you 10,000, how much will you give me? 10,000, but you have 1 lakh, right? Chalo. If I ask you 60,000, how much will you give me? But you have 1 lakh, right? Why are you not giving? So if I ask you 2 lakhs, what will you do? Then you will say, sir, I have only 1 lakh, take everything. I can't give more than this. Are you getting it? Just because I'm asking you 10,000 doesn't mean you have to give me 1 lakh. You will give only how much ever is required. Are you getting the catch? You are capable of giving 1 lakh, but you will give only how much is required. Are you getting the point? Friction does the same thing. I can give you 25. It doesn't mean I have to give you 25 every time. I will see what is the requirement and accordingly provide. Is this making sense, everyone? Now, did you observe one thing? मतलब friction का magnitude भी पता नहीं हमको clarity से. It keeps changing. So you have a force whose direction does not depend, can change. You have a force whose magnitude can change. So there, that is why this is the whole chapter. Now, if you know these two things, it is just a laws of motion ka question. So we are dealing with a force whose direction and magnitude can change on a whim. So yeah. Is this clear, everyone? I hope got the story here. So whenever you think like friction ka magnitude kitna hoga, remember that 1 lakh ka thing. If you have 1 lakh, if I ask you 20,000, you'll give only 20,000. You won't give 1 lakh. So friction does the same thing. I can give you F max, but I'll give only how much ever is required. Therefore, anytime someone asks you what is friction, always say friction is less than equal to mu Sn. Never say equal to. If they ask you what is the maximum friction, then equal to. So that one word, right? Fs max, Fs are totally two different things. Clear? So that is the theory about friction. So next class when we meet, we're going to do problems on this. So next class we'll do some pretty good ones. Chapter is quite small. Like I said, it just looks like NLM after this. We should wind up this in 2 to 3 classes. The questions will be quite good in NLM. So, okay. So with that, we'll wrap up for the day. So we'll catch up again on Friday as usual at the same time. We'll continue from here. So make sure to go through the friction notes and do resolve all the 51 problems of laws of motion which you have done. And plus, I'll send you a sheet also today, maybe 40 questions, not much. You can do that. Okay. So those are doubts. Anything, please stay back or else you're free to leave. I'll see you on Friday.